Hello, students. In this lecture, we're going to talk about algebraic approach to self-correcting codes. In the previous two lectures, we used visual approach, where we used Venn diagrams, but computers can't really recognize Venn diagrams, so we need to take this approach and convert it to a way that computer can perform these actions that we did by hand last two times. So what do we have? We have a message word. We have a message word which consists of M1, M2, M3, and M4. And we have check digits C1, C2, and C3. And if we create our diagram, which we would like to convert to algebra, we have M1 over here, M2, M3, and M4. We have C1, C2, and C3. Let's call the circle to be A. Let's call the circle to be B. And let's call the circle to be C. So what is our scheme? Our scheme is relatively simple. For circle A, we have the sum of M1, M2 in this circle, there is M3 in this circle, and if the sum comes out to be even, that means our C1, maybe words are better here, then C1 has to be equal to 0. Or it could happen that M1 plus M2 plus M3 will be odd number. Then our C1 has to be equal to 1 to switch it into an even. And the same is true for the circle B. In circle B, we have M1 plus M3 plus M4. And if it comes out to be even, then C2 has to be 0. Or M1 plus M3 plus M4 might come out to be odd. Then C2 has to be equal to 1. And there is one circle left to do. It's M2, M3, and M4. M2, M3, M4 could be even. Then C3 has to be 0, or M2 plus M3 plus M4 could be odd number. Then C3 has to be 1. C3 has to be 1. So that's our scheme. There is nothing special about it. This is relatively simple for computer to handle. So let's look how we can do it just by using algebra without using Venn diagrams. So let's look at the example. And in this example, if the message word is 1001, we need to create a code word. Create a code word. So in other words, come up with check digits, right? So find check digits. We have to find check digits. So let's do this out. So we write it out. So part A, first circle is M1 plus M2 plus M3, but maybe we should write what M1 is. M1 is 1, M2 is 0, M3 is 0, and M4 is 1. So part A tells you, take the first circle, M1, M2, and M3. So we have 1 plus 0, which is 1, which is odd, which means C1 has to be 1. Then we go to circle B, in which we have M1, M3, and M4. M1, M3, and M4. So we add them up, we have 1 plus 0 plus 1. And so we get 2 even number, which means C2 has to be 0. And the last circle C, which has no M1, so we have M2, M3, and M4. M2 is 0, 0, and 1, so we get 1, which is odd. And C3 has to be equal to 1. So conclusion, our code word is 1001 that comes from the original, and then we add our check digits 101, and that's the message that we're going to send over. So we figure out the code word. So what's the next example? The next example is like this. The next example that we have is like that. If code word that we get is 0010 and 010, find the message word. Find the message word. So we need to find the message word. Let's try to do that. So we go through, we find M1 is 0, M2 is 0, M1, M4 is 0. All right, so let's go through the procedure. We have to add M1 plus M2 plus M3 for circle A. So in our case, 0 plus 0 plus 1, which is equal to 1. All right, that's odd number, so C1 has to be 1. But if you look here, C1 is equal to 0. Is not equal to 0, which comes from here, right? So something went wrong in circle 1. So we have to check circle 2 before we do any action. So M1 plus M3 plus M4, which is 0 plus 1 plus 0. So we got the answer is 1, which is odd. So C2 has to equal to 1, and C2 we put it here, and indeed it's equal to 1, so this is fine. So we put a check mark. This is fine. Right, this is fine. Then the last circle doesn't have M1, so it's M2 plus M3 plus M4, which is 0 plus 1 plus 0, which is 1, which is odd. And C3 has to be 1, but if you look here, it's 0, right? So if we put it here, this is not equal to 0. So something went wrong in this circle. That means what? That means that we have to change the message bit between so circle 1 is off and circle 3 is off, between A and C, right? Between A and C. So basically what you do, you have to find a common one between circle A and circle C, and there are two things that are common to both of them. M2 is common to both of them, and M3 is common to both of them. But unfortunately, M3 is also common to circle B, so we cannot change M3. We only have to change the one that's only common to both A and C, but not to B. Right? So that would be M2, and M2 was 0. So we have to switch it to 1. So what would be our message word? The message word is equal to, so we take the original one, which is 0, 0, 1, 0, 0, 0, 1, 0, but second one shouldn't be 0, it should be 1. So we switch it into 1. And that's our answer for this exercise. That's our answer for this exercise. So let's move to the next example. In this example, code word is 10111101. Find the message word, the same assignment. Find the message word. So our M1 is 1, our M2 is 0, our M3 is 1, and our M4 is 1. So circle A is M1 plus M2 plus M3. So it's 1 plus 0 plus 1, which is 2, which means it's an even number. And so C1 has to be 0. C1 has to be 0, but we see that C1 is 1, is not equal to 1. So something went wrong. We move to circle B, 1 plus M3 plus M4. The second circle doesn't have M2. So in our case, it's 1 plus 1 plus 1, which is 3, which is odd number. So C2 has to be 1. But we can clearly see that it's not equal to 0. So something went wrong in this circle too. And the last circle to check is third circle, which doesn't have M1. So it's M2 plus M3 plus M4. So in our case, it's 0 plus 1 plus 1, which is 2, which is even. And so C3 has to be 0, but we can see that it's not equal to 1. So something went wrong in all three circles. So we need to find something that is in all three circles. We see that M6 is the only item that is present in all three circles. So M3, which is 1, has to be switched into a 0. So our message word, our answer, message word is equal to 1011. But remember, M3 we switched into a 0. So it has to be 1001. All right, so we did a few examples. I think you figured out the way. Again, if all three circles are fine, then you're all set. And in the next lecture, we will start talking about methods for more than one bit errors. And I'll see you then.